Hello, I'm Richard Patterson, and I'd like to welcome you to this film where we're featuring the IPC Irwin van der Graaff machine. Now, this is a very popular piece of equipment in senior high schools. It's often brought out in parents' evenings and at science fairs because it has lots of very attractive qualities. You probably know it can charge up someone's hair and make their hair stand on end. And there's lots of different experiments that you can do with this and demonstrations, which you'll find in our teaching notes. But let's just look at how this machine is set up when it comes out the box. You need to mount on this steel dome on top of the machine and make sure that it's all dry and ready to go. So we have a motor here driven from the mains with speed control, and this pulley drives a pulley connected to a roller at the base of the machine. Now you can see from these close-up shots that by the roller and the belt, there's a metal cone with some teeth on it. And this machine basically transfers electrons from the cone up the belt to a second cone, which is inside the dome at the top there, and the electrons then move out to the very outer surface of this dome. And they stay there because it's surrounded by an insulator, air, and the base, this support of the machine and the belt are insulators. So we have electrons moving up and going onto the dome there. Now, because electrons are negative and they repel each other, each electron will try and get as far away as possible from neighboring electrons, which is why they cover the outer surface of the dome. So around the dome, there's going to be quite an intense electric field. And in terms of current flow, if we switch the machine on, we can discharge the electrons and they'll move, and a moving electron, of course, is an electric current. And we have this accessory that comes with the Van der Graaff machine, this small metal sphere. Be very careful when you're using this incidentally, not to bang the dome, because machines I've seen in schools often have little dents on the dome, which doesn't help it work at all. But there's a wire running down here, and it is connected to a socket at the base of the Van der Graaff machine, and that socket is connected to the cone again. So when you see the machine discharging, we actually have an electric current running around here. This is an excellent introduction if you want to move between electrostatics, that's static charges, and moving charges, electric currents. So we'll switch the machine on, and you probably can't hear me because of the motor noise, but just listen for the crack of the air conducting electricity, because if we reduce that gap to around between 1 and 4 centimeters, the air will be ionized by the intense electric field there. It will conduct the electrons, and they'll move from the large dome to the small dome there, making electric current. Before you touch the dome, it's wise to make sure it is discharged there, because whilst it won't harm you, touching the dome when it's charged up will give you an unpleasant shock, because the electrons will be coming through your body down to Earth, and you feel that as a little jolt. The machine, by the way, is quite safe to use, because whilst we'll talk about voltage later on, the size of the current is very small. And the only thing you need to worry about, this is covered by the CLIAPS notes, which you can look at via the QR code, is if there's anyone, any of the teachers, any technicians, and of course any students who've got heart problems, it's best for them to stay away from the machine, and 1 meter distance is considered safe. So let's look at a few more features of the Van der Graaff. Some students think the Van der Graaff's energy is coming from this main supply here, but really all it's doing is driving the pulley. So the IPC Irwin model has a removable pulley, and we could add a second pulley to this hand wheel like so. And when I come around and drive the Van der Graaff by turning the handle, you can now hear, without the motor noise, the machine discharging through the air. So in terms of energy, the energy transferred to the electron store at the top of the dome is basically from me just turning the handle like so. And the more energy are transferred by turning it faster, the greater the number of electrons go to the top. In terms of that other electrical measurement, voltage, the Van de Graaff machine achieves a voltage between Earth and the dome of 100,000 volts. And that's required to ionize the air when you hear the machine discharging and when you see the spark jumping across there. Now 100,000 volts sounds a lot, but remember that in terms of the size of the current, which of course is one of the dangerous things in electricity, the size of the current is very, very small. So the 100,000 volts, whilst it sounds quite large, in this case is quite safe. The Van de Graaff machine comes with a range of accessories, one of which is this, what we call a head of hair. It's just nylon threads, which are just attached to the top of this metal post. So making sure that the machine is discharged, you can slot that into the top of the machine there, and then you can ask your students what's going to happen when we switch on again. Well, lots of them will say the head of hair will rise and we'll get this hair-raising experience, but we want to know from the physics why it's doing that. And I hope you'll elicit the response that the strands of hair, electrons are moving onto the strands of hair, and the negative electrons on each strand are repelling each other, and so we have electrostatic forces, repulsive electrostatic forces between the heads of hair there, and you can see the hair is moving around to my hand because it's got a way for the electrons to transfer down to Earth there. One of the accessories that comes with the Van de Graaff generator is this little neon lamp. So inside the glass capsule there's neon gas. So if we place that on the top of the dome like so, the high voltage will ionize the neon, and in doing so, it will give off a characteristic orange light. So if I switch that on now, we can just see the neon light emitting orange. So as an extension of this demonstration, it's interesting to think about a free body diagram of the pie case sitting on top of the Van de Graaff machine. Now, if we think about the situation there when it's uncharged, the pie case isn't moving, so we do have a downward force caused by the weight, counteracted by an upward force, the reaction of the top of the sphere. So why does it move? Well, the electrons will move to the surface of the pie case, and the electrostatic repulsion force between the pie case and the dome will be upward and sufficient to levitate, move the pie case away from the dome, and then it floats down. So it's a nice thing to do with GCSE students when you're doing forces and when you're looking at electrostatic repulsion and Coulomb's law, to talk about that with senior high school students. So one of the most interesting demonstrations you can do with Van de Graaff generator is to put these aluminium pie cases on the top, and we'll switch on and we'll observe what happens. The Van de Graaff machine will give you many years of reliable service, but remember there's certain things you need to maintain because moisture is the worst enemy of electrons being discharged from the dome. So the first thing is your classroom, your laboratory. If it's a damp season, damp environment in the classroom, then the machine is just not going to work properly at all. So try and choose a dry day wherever in the world you're using this machine for it to work properly. Secondly, if there's any moisture in the frame of the machine, that's as well as going to mean that charge comes down and goes away from the dome, so it's not going to work properly. So we can use a plastic hairdryer to dry out the machine. We want to point it at the roller, the comb, and the belt. If there's any finger marks on the machine, I put alcohol will again allow you to remove those. And the other thing is the dome itself does need polishing as well to make sure there's no dirt and dust on there and finger marks. And again, don't make sure that the discharge dome doesn't dent the upper sphere there, because that's not going to help either. From time to time, the belt itself will need replacing, because you'll get cracks in there which will interfere with the charging process. So if you want replacement belts, one comes shipped with the Van der Graaff, and any more can be obtained from IPC Irwin's service department. Similarly, the pulley wheels there, the two pulleys can be replaced as well should they become loose or break.